Welcome. I'm so glad you're here. I'm Cindy Zulsdorf here with the openGear Leader Partners, and this is all about, in case you missed it, at NAB. So if you didn't make it to see all of the openGear Leader Partners at NAB, we got you covered. Stay with us for the next 30 minutes. You're going to hear about the best of the best, the gold. You're going to find out about the newest signal processing applications and gear that's going to make your life, your job easier, your workflows more efficient. And up today with you, and everybody's going to do like a 5-6 minute segment. So you're going to just get cream of the crop here from Ross Video, Cobalt, MultiDyne, VITEC, and AJA. So we are going to start off here with Darren Ward from Ross Video, and he's got the inside scoop on openGear, where it's been, where it's headed. So you're going to get a sneak peek into where it's headed. And he's got an inside scoop on some new 12G SDI gear. Darren, over to you.
Cindy, thank you so much. Thanks very much. So I will jump in here. NAB 2026 was a big year for openGear. It was the 20th anniversary, so we're in a bit of a celebration mode on that. Was a nice milestone for us, and a bit of history on this. The first openGear frame was launched way back in 2006. It was the DFR 8310. That was developed with Cobalt and Ward Beck and Ross. We were the first three founding partners. And now if we fast forward to 2026, we've got our lead partners on the call today, who Cindy mentioned, but the ecosystem's actually grown to over 150 individual partners. And easily it's the broadest modular processing platform in the industry today, with the contributions and the products that are available from everybody. This open ecosystem has led to some healthy competition amongst us, where products overlap. So that's something that's been pushing innovation and keeps us all honest with better pricing. But at the same time, there's openGear partners who develop products that fill very unique niche applications, and that adds even more depth to the whole thing. So, if we take openGear from that standpoint and we compare it to proprietary systems that are out there, ones that have more limited choices that are dictated by those vendors and suppliers, or look at ones that we all know about that are late in their life cycles or maybe even have been discontinued altogether. openGear continues to remain strong. The first cards we made are still forwards compatible with the latest frame. So that leaves openGear as really the most stable and safest long-term modular platform that's out there. And at the core of this has always been the frame. So currently at our fourth generation, which is the OGX frame, it has evolved to support power and cooling needs for the latest processing, IP especially, and dashboard, which is the free and open control system, and that works across the entire ecosystem and all of the vendors. So yeah, again, on the 20-year milestone, we're pretty excited. And the openGear partners and Ross here on the webinar today are excited to show you some of the new things that we've got going on. So let's go ahead with that. So at NAB, how fitting was it that the first product introduced for openGear in 2006 was distribution, and we introduced a couple of new products there. We launched a 12G SDI distribution amplifier. This replaced a couple of older products in our line that were due for a refresh. Arguably this is still one of, if not the most important piece of glue in any piece of infrastructure. So we launched a new 1x5 and a new dual 2x10 product. Both support 12 gig SDI. The dual channel also has a cross point inside. So you can do routing between the inputs, and you can set it up for automatic failover. And, tell you what, these days, I think we're all feeling the pain when it comes to pricing. And we did a clean sheet design on this thing. So with that, we're able to lower the cost as well. And we passed that on with lower pricing compared to the models that it replaced. I don't think we're hearing that much very often these days, but it's a nice thing that we're able to do that, and glad to be able to pass it on to everybody buying these products. But with that, I'll move on to something else, because honestly, how much can you say about a DA? moving into something a bit more interesting, ROS Platform Manager and Master Control. So this is something we're demonstrating at NAB this year. Of course, the MC1 Master Control is our hardware-based master control switcher on an openGear card. This is something where you want a hardware solution for high-value air chains where reliability and latency are big concerns, and it's absolutely essential where we've got high-value content. And a product like this differs from, let's say a channel in a box, where MC1 has a more deterministic behavior and performance. And we highlighted this product in the context of RPM, which is ROS Platform Manager, and use in distributed workflows. In this case, we modeled after a large RPM deployment that's in place in the field and live, and it's managing a nationwide multi-site master control setup. Now, how does RPM play here? Among many other functions, RPM provides secure and browser-based access to dashboard-enabled devices. It moves from being a client-based setup to a centralized hosting of the system. So all the custom panels are put in one place. And as far as distributed applications go, it definitely simplifies deployment. Operators get a nice, consistent experience from anywhere because they're logging in with a browser and they've all got the same thing under the hood. And anybody managing the system certainly enjoys the centralized administration and updates. So the screenshot that we've got here is the MC1 on-air control interface. So if anyone's familiar with that from dashboard, you'll certainly recognize that. But yeah, one thing I want to note here is that RPM is a complement to dashboard, doesn't replace anything, and it works in conjunction and alongside of it. So this is a new thing that's available. It's in beta right now, but yeah, as I say, deployed and something everybody can get. And moving into one more thing, SRT, applications like distributed production, distributed facilities, remote venues are continuing to drive demand for transport between sites and even to the cloud. So this was something we're excited to be able to show was a ground-based product in openGear, now meshing with a cloud-based product. We've got openGear talking and connecting with the cloud. So this is our SRT gateway on the ground on a openGear card for SDI, and an SRT gateway in the cloud as a SRT to NDI translator. So we're able to complete that entire workflow, ground to cloud, and control the whole thing in dashboard, of course, top to bottom. So from there, we will come back down to earth, and I'm going to pass this over, I believe, to Cyril, who's got something actually really exciting to show us, and it's a topic that's near and dear to my heart. So I will hand it over to him.
Thank you so much, Darren. Appreciate you showing us that. That looks great. And Catherine or Fallon, you can just help Darren unshare those slides if you don't mind. And Ciro, I'm so glad you're here.
Thank you,
Uh,
Cindy.
yeah, give us just a moment and we'll throw to you because I know you, Sarah, are going to get into C-band going away and what to do about it. And Sarah, you and Cobalt have come up with a great solution on doing that. Before we throw to Cyril, I want to answer your question. One of you asked, is there a place to find all openGear information? The opengear.tv website, you can see cards from everybody here on this session today and other partners as well. So Ciro, over to you on C-band going away and what to do about it.
Thank you, Cindy. So, like they say, for now, something completely different. I got to give a shout out to the Cobalt product line. We've been a founding member of openGear. We have a number of product lines, both in openGear form factor and in standalone form factor. We're big in IPMX. We have DAs, we have frame syncs, we have processing, we have encoders, we have decoders. We're big in wrist and also have SRT for those of you who want that. But instead of talking about a whole bunch of cards here, I'm going to talk about satellite. So it's weird when you put an FCC NPRM, Notice of Proposed Rulemaking, in a slide, but that it is. C-band is going away. The FCC has been mandated to sell off about half of it and authorized to sell off all of it. And what we are hearing is that it's going to sell out all of it. So C-band goes away, and what you're going to do about that if you use that for contribution. So what can you do about that? You can use the internet. Like, I mean, there's RISC, there's SRT, there's a whole bunch of stuff. So you could use the internet, but the scaling is a problem. And every additional receiver includes OpEx. This can get expensive because for high-grade professional internet links, you're paying by the bit. Or you can go to KU band. KU band has gobs of bandwidth in KU band, and the antennas are smaller, but KU band is subject to rain fade. So when it's KU band is those 19-inch dishes you see around there, and you know when it rains, you lose it. It's a sort of okay for consumers, but not for professional, right? For contribution. So what about we combine the satellite and internet delivery? The satellite does the bulk delivery, and internet is used to fix any holes. It's just like transmission over the internet. There's packet loss and you fix the packet loss. But now transmission is over satellite and you fix the satellite. But it got to be backward compatible. So this is something that Cobalt is involved in, but it's an open specification. It's VSF TR-06 for part 7, which is part of the RISC specifications. So that's a way to solve this problem. You can see here in the diagram that you start with the transport stream. There is something I'm calling a processing tap that adds some backward compatible information to the transport stream, and then that information allows you to recover the packets, basically the limits on the transport stream where the RTP packets would be. And with normal settings, that only eats 22% of the transport stream bandwidth. So you can definitely afford that. That 2% is going away as no packets. Any lost data is recovered over the internet. If you're doing Cobalt, we have some solutions for the headend, and we have some solutions for the receiver. But I'm putting another hat here because I'm the editor of the RISC specifications. This is an open specification. There's multiple companies working on that. Now, since this openGear, we've got to talk about an openGear card. Cobalt has a new generation decoder, and a shout to Darren, it's cheaper than the previous generation. That you now can get with the L-band input with the satellite demodulator. So it's an openGear decoder card, can also work as a SAT demod. It's a DVB-S S2 and S2X is coming. It's factory installed. It does support TR-06 for part 7. It supports the stuff that you expect, LNB power, so you can power LNB from it. Not everybody can, but you can here. You can do polarization control, and we even support the 22 kilohertz switch. If dissect comes back, I'll support that as well. And when you receive the satellite signal, you can decode it, because this is a decoder, it's not just a demod, decoded. You can put it out over ASI, and you can put it out over IP also simultaneously. You can do all three things simultaneously. So we had a demo at NAB New York back then where I used a legacy IRD. So I started with a Cobalt encoder. That demo I also did with Zixi. I had a Zixi sender as well. I put some piece of software that pretended to be a satellite link that had losses. And then we drove a satellite modulator using a Cobalt gateway. And on that demo, I used the MediaKind RX8200 as a legacy IRD. So the output of that was glitching like crazy, and the ASI of that came to Cobalt decoder that was recovering the packets over that risk recovery path that stood in for the internet. So I had a nice multi-view with side by side. This glitches, this doesn't. But that was last year in New York. I had another demo here at NAB using now my own satellite receiver. Same thing, a Cobalt encoder, loss emulator in the path, and then you drive the drive L-band into the decoder. In that case, I had one path, the raw signal, and another path, the recovered signal. And that obviously it's kind of them we used to do way back in the day when internet delivery um, wasn't as common. Here you go with packet loss and without packet loss. It's the same demo, but one is cleaning, one is not, showing that I can get a one-way backward compatible transport stream and recover that. And using an openGear card. This was all an all openGear demo. It was all in an openGear chassis. So if you missed NAB New York, NAB Las Vegas, this is what you would have seen there. And that's the solution we are talking about. We were also in another booth. The Zixi booth was having the same demo with Cobalt, and there's other vendors working on this. So this is hot, and this is going to happen. And as I
So
promised
great,
Cindy, I was
Sarah.
going to
I
talk
thank you
very
for
fast,
that.
and I'm done.
Appreciate
So
that. Nicely said.
my pleasure.
For those of you asking about applications, we've got an applications guide with the top applications for openGear cards, equipment from everybody on this webinar. I know there's several of you I can see in the audience here who use openGear right now. So you may have you'll have new ones you can learn about, and you may have other ones you're doing. But grab that openGear Ultimate Applications Guide. We'll put the link in the chat for you. Okay, over to you, Jesse at MultiDyne. I know you're going to get into SDI-IP hybrid setup for multi-camera cinematic workflows. Yes.
Thank you for the intro. Are you guys seeing my screen? So the stars of the show here are the OG 7800 series and the MDOG 6060 and 6061, which has JPEG XS. And what this card set will do is allow you to do a hybrid SDI IP workflow today to allow you to migrate and transition your facility and your workflow to be all IP in the future, but don't need to jump into it right away. So these engines that I'm referring to here, I refer to them as engines here. The 7800, you can get it with audio, 4 channels or 8 channels of audio, up to 4 12G SDIs, a bunch of camera-centric signal support like Genlock and timecode. This actually is AES in the transport, so you could homogenize everything from analog to AES or vice versa through the transport. And the 4610 or the 7810 that you see below there cancels out the audio, and then it becomes a 2-slot rear module, but still supports all of that ancillary data and the 4 12G SDIs. That could be bidirectional, unidirectional. The directionality can, it's an order option essentially. So a fully stuffed frame, you see 10 cards in there. We have the cross compatibility in our line, openGear to openGear, of course, openGear to Silverback. So you'll see slides showing the base station in the openGear with the camera adapter. VersaFrame is our popular 1RU bulk distribution system that has support for all these ancillary data signals as well, including audio. So you can build openGear on one side and any other system on the other side, including VersaBricks, which is one of our most popular platforms and does the PTZ work for us. So on that front, I just wanted to show a popular application is up to 10 full PTZ extensions in 1 2RU frame. And that's including everything you need to send Ethernet. If this camera system uses serial data, we can send serial data. If it needs tally, all of that is built into this card and can support up to 10 links in 1 frame. Another application with this hybrid nature of our VersaBricks working with the openGear in the machine room is SDI over 1 fiber. Hit the VB box at the back of the displays, turn that into 10 discrete HDMI 2.0 outputs with HDR with redundant power for critical applications. So now getting into the gateway product. So this is a ST2110 gateway, proper 2022-7 failover support, has 2 NICs. It's all a function of bandwidth. So the versions on the left-hand side, the 2-slot rear modules, are the 12G SDI capable versions. You see there's dual in, dual out, or transceive. And then on the HD 3G side, we have a range of 3x3, 4x4, 6x2, and 2x6. So you'll see what that allows us to do is build, hybrid SDI and IP architectures for live cinematic multicam, which is one of our, market segments that we pretty much lead in North America. So we can turn any digital cinema camera into a television studio camera with power over SMPTE hybrid fiber, and all of these signals bidirectional over that fiber. And what I'm showing here is, an adjacent gateway to the base station card in the frame. And this is a subset. We could actually fit more of these in one frame without audio. If these had audio, this is what would fit. But I'm just showing 12G on the network, 12G off the network for return. If you happen to use the 3G product, then you could put, multiple cameras on and multiple returns off in one card just because the density is higher. So this is the 2RU flagship base station that the Silverback uses. We have the openGear option, like I've mentioned, and the VB can also be a base station, but the 2RU flagship base station has 4 openGear slots. So it could support 2 of the 12G gateways or 1 of the 3Gs that are, 4 slots wide. And then you could do, on the 3G side, 2 cameras on the network, and then, up to 6 feeds off the network to feed your studio floor with talent monitors and teleprompters and any kind of return signals you need to take off the network. So this is a kind of application drawing I put out, and the AJA guys thought it was kind of cool. It just shows the fact that openGear brings it all together, and you can pick and choose the best of breed that you want to use. So this is, our base station card next to a color processing card from AJA next to our gateway. So it's a full 2 camera chains with processing in a 2RU frame with redundant power, remote monitoring, and control. And last thing I have to mention is IBC Preview. It's an MDOG 8800. It's an 8-channel 12G SDI to coax. It's got a cross point in it, so it's essentially a router and a fiber extender. We have versions for per fiber, like you see on the left there, and then we have CWDM, where we'll be able to get all 8 out over 1 fiber, and then cascade to an adjacent card to get 16 on 1 fiber using 2 cards. So that's what I had today to share, and hopefully there's something that you thought was interesting.
Thank you, Jesse. Well said. Lovely summary. Love the applications and the diagram you made. That was really useful. So stay with us. I know this showed up on your calendar invite as a 35-minute webinar, and we're right on track with that. We have coming up next VITEC, but stay with us because we have AJA coming up after that, Barry with AJA. So first, Grant, at VITEC, you've got a new encoder to use in 2110 systems, whether it's remote contribution, multi-site, other applications. Tell us all about it.
We do indeed. Thank you very much, Cindy. So hi there. As Cindy said, my name's Grant. I am from VITEC. I'm the head of product marketing. So if you were lucky enough to be at NAB, you would have seen our brand new openGear compatible Diamond IP OG. It's a brand new encoder blade that was launched at NAB this year. And it's for 4K and multi-channel SD and HD video. It's a brand new addition to our VITEC OG range, which is an openGear compatible range of encoders, and we also offer a decoder card as well. So this is compatible with as Darren said in the OGX frame from Ross Video, and it's actually our first openGear compatible encoder, which supports low latency streaming from 2110 sources. And the thing we're probably most proud about is that we actually won a Best in Show award at NAB 2026 from TVB Europe, which was very nice to see all that hard work being recognized. It's actually our 4th openGear compatible encoder blade. We have various different options with different inputs that are compatible with the openGear ecosystem. So we'll talk a little bit more about the Diamond IP OG. So for those of you who might not be familiar, I'm sure most of you are, but just in case you're not, 2110 is an IP input typically used in the broadcast production environments. These environments are moving to 2110 for flexibility, but not only is it being used in these broadcast environments, high-end venues are using it. I believe, don't quote me on this one, but I believe the Sphere in Las Vegas is using 2110 for its streaming as well. So when these streams come in, they're large streams, 12G uncompressed. So what the Diamond IPOG does is it takes these streams, compresses them for bandwidth optimization. So it can receive either the uncompressed 2110 streams, or it can take in compressed JPEG XS streams as well. So it supports both of those. Another neat feature is its 22/7 hitless redundancy capture. So you can see on the image on the right hand side there, you've got two SFP ports, so we can capture the same stream, receiving two identical streams coming in, so that if one fails, the other one can take over, which I've been told is referred to as red-blue networking in the industry. So something I learned this morning, which is pretty cool. It does HEVC and H.264 encodes, and that's either one 4Kp60 or four 1080p60 encodes, and also has up to 8 output streams from that one stream coming in. Another neat feature on the Diamond IPOG is its NMOS stream discovery and registration. So obviously when you've got lots of cables, HDMI, SDI being plugged into traditional encoder blades, you can label the cables. It's very easy to see which feed's coming in, which feed isn't. Obviously, much more difficult with IP. No physical cables to take a look at. So what the NMOS stream discovery and registration does, again, I may be preaching to the choir. You may know all about this already, but just in case you don't. So this allows easy management of these IP streams, capturing the different either 2110 or JPEG XS streams which are on the network, and then captures them, encodes them, but allows for that easy identification, which is great. Obviously, VITEC, we pride ourselves on secure video transmission. So the Diamond IP is no different. It's got stream protection built in for that reliable video, audio, and the metadata transmission. And of course, wouldn't be here if we weren't. It's openGear compatible. Form factor does allow for real range of flexibility depending on what chassis you wish to use. And I mentioned it before, it expands our openGear compatible offering, which now includes 2110, SDI, HDMI, and composite capture and encode. So thank you very much. If you want to check us out at vitec.com, and you can find out more with the link that Fallon has put in the chat. Thank you.
Grant, well said. Good to hear about the red and blue applications and NMOS discovery. Always a welcome topic. So thank you for telling us about your encoder. That was fabulous.
Thanks for the opportunity. Thank you.
Barry at AJA, I know you've got some good information on reference, sync generator, and over to you on that, on the OG Gen 10.
Hi, this is Barry Gotch, Product Marketing Manager for AJA Video Systems, and I have some great news from NAB 2026. Before I get into the news, I want to talk about reference. The reference is the heartbeat of your production, where it time aligns all the different devices that are part of your production: cameras, replay, routers, multi-views, converters, frame synchronizers, audio embedders, and de-embedders. All the things that you need to work in time with each other to ensure clean switching and glitch-free production, and to make sure that all the signals are aligned. That comes from this heartbeat from the reference generator sitting at the middle of this production. And we've had a device on the market since 2007, the Gen 10, which has provided sync to literally thousands of shows all over the world. And it's been a very successful product for us. And it has 6 reference outputs and a 7th output for AES-11. But we've seen the growth of environments and productions that need more, even more sync outputs than 6. So we've developed and new for NAB 2026 an openGear version of our Gen 10. The QR code on the lower left goes straight to the product page to get more information about it and also to learn where to buy the card. So the OG Gen 10, the key differentiator is that it has 9 outputs instead of 6, and it has 2 groupings of outputs. So you can have SD sync or HD sync, or you can have 2 versions of HD sync, and we support up to 19 different frame rates of sync in HD. So we're basically covered with any type of production that you're going to do. Now this is a view of the board, and on the left you can see there's a silk screen on the board showing you the groupings, and then also the dip switch control that is a throwback, but still may be useful for your production if you don't have access to the dashboard software to configure the board. You can do it directly on the board with the dip switches. And of course, you can control the OG Gen 10 through the dashboard software, which is cross-platform Windows, Mac, and Linux. And you can control all the boards in your frame with this software. So you have the single pane of glass for controlling all the operations inside of your openGear frame. And so here you can see a use case, a common use case of the reference. Our gear, we want our gear to be in time with your entire production. And so our gear has reference inputs on it, the frame synchronizer on the lower right, the router on the left, the digital recorder on the left, the camera will have a reference input, so you can have all of these devices running together in sync. There's the audio output, the audio reference going into the digital mixer, and you can see that there's reference from the board going into the frame itself, and so that signal can go and supply a reference to all the boards inside of your frame. And that's a really exciting possibility that you can run reference. The openGear frame itself has 2 reference inputs, so you can supply 2 different frame rates or styles of reference into the board, into the frame. In addition, the frames have a loop through, so you can supply reference to an entire signal chain, an entire production from this one board. And where would you use this device? In any number of production environments where you need to have everything in sync with each other, whether it's a control room, a flight pack, mobile truck, production studio, and most interestingly, and thereby the need for having more reference outputs, is that you have these virtual production stages where you need to have the LED walls, the Unreal Engine computers, the cameras all in sync with each other, and there's just this need for more sync and more reference going to these environments. And so that this is a perfect fit for that production opportunity. The OG Gen 10 is shipping now. It's $795 US MSRP, and it includes our 5-year warranty. So in sum, you can see the snapshot that we've got the 2 different groupings for the sync, 2 different types of sync, SD and HD. You get dual power supply options with the openGear frame. We have AES-11 sync as well. And you can control the board via the dashboard software or the onboard dip switches. So be sure to follow us on social media for the latest news and updates. Thanks so much for your time, and back to you, Cindy.
Thank you all.
Right.
Thank you, guys.
Thanks.
Thank you. Bye-bye.
Bye.
Thanks, everybody.